Hello children. So today we are going to start exercise 7.3 sum number 1 in chapter triangles. ABC and DBC are two isosceles triangles on same side BC. Vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, show that these are congruent, this bisects and this is perpendicular bisector. So we will take one at a time children. So the first thing which we have to prove is triangle ABD is congruent to triangle ACD. So this is your diagram. So they need only ABD, that is this triangle, and ACD, this triangle. So we don't need this. So we will just remove this off. Okay. Now we know children, they have said that ABC and DBC are two isosceles triangle. ABC and DBC are two isosceles triangle, and we know that in isosceles triangle two sides are equal. That means AB is equal to AC is given. AB is equal to AC given. And in this isosceles triangle DB is equal to DC. That is also given. So DB is equal to DC. Then what is the common side in both the triangles children? AD. So this is your third common side. AD equals to AD. Now all these are side, side, and this is also side. So by side, 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 you can say ABD is congruent to ACD. Now if I make this as CPCT, if I try to take congruent parts of congruent triangles, I can say ABD as BAD also. So BAD angle is equal to same pattern CAD. First B, middle part, and here middle part is C, then first part A, and then the last part D. So these are congruent parts of congruent triangles. So if you look at in this diagram children, BAD is equal to CAD. How does it look? BAD equals to CAD. That means these two are equal. But can I say BAD as BAP also? Yes, because AD is just extended. So BAD can be called as BAP also. In the same way CAD can also be called as CAP also, because the patterns are not changing. So I can say therefore BAP is equal to CAP because they are lying on the same line. But if BAP is equal to CAP, that means this AP line is cutting angle A into two equal half. That means AP is bisecting angle A. AP line is cutting angle A into two equal half, and that is what you have to prove in the third point. AP bisects angle A. So we have proved this also. Therefore, we can say AP bisects angle A. So we have finished this and we have finished this. Now next part. Triangle ABP is congruent to triangle ACP. That means ABP, this full triangle, is congruent to ACP. That means we don't need this, so we will remove this. And in this already we know these two sides are equal. Okay, and just now we proved these two angles are equal and this side is common to both the triangles. So I can say for second point, in triangle ABP and triangle ACP, AB equals to AC, and just now we proved BAP is equal to CAP here. So this is our first equation. So I can say angle BAP is equal to angle CAP proved above. And then AP is common to this side also and this side also. So AP is equal to AP. This is given and this is common. So what is this side? This is angle and side. Look at the pattern children. Side, then angle, and then side. So by side angle side, this is congruent to this. Okay. Now from this I can see one thing children, that BP is equal to CP. Why? Congruent parts of congruent triangles. And why do we need this? We will later come to know. So we can say BP is equal to CP, CPCT. Okay, now let us move. So we have proved now this also. Easy. Now let us go to the third part. Now in third part, we have to prove AP bisects angle D. That means you have to show that AP, this line AP was here like this, right? That means you have to show AP is cutting angle D also into two equal parts. So what do we need, children? We don't need this diagram. We need only BCD, like this it is. BC and DP. We need this. So AP is just extended till here, right? So you have to show that AP is bisecting angle D also. So I'll show it here itself. Here we have just proved BP is equal to CP. So BP is equal to CP. That is your first point. Proved. And we also saw that this DP is common to this angle also and this angle also. So you can say DP is equal to DP common, and BD is equal to CD. Why? Because they are two sides of this isosceles triangle. So BD is equal to CD. This is given. So if you see, all are SSS. So we don't have to look at the pattern. So by side, triangle BDP, that is this triangle first, is congruent to triangle CDP. That means if the triangles are congruent, the angles are also equal. CPCT. And what does this say as? BDP is equal to CDP. That means these two dots are equal. These two dots are equal. That means this line is cutting angle D into two equal parts. That is what we have to prove. Therefore, we can say angle D bisects angle D. AD bisects angle D. Because this BDP is equal to CD. Now we have proved this also. Now coming to the last statement, AP is perpendicular bisector of triangle ABC. Let me draw this triangle again, children, so that it is easy for you to understand. They are telling AP is perpendicular bisector of BC. What is the meaning of perpendicular bisector? Perpendicular means you have to show APB is 90 degree and that this AP line is cutting BC into two equal half. That means this should be equal to this. That is the meaning of bisector. AP line is cutting BC. AP and BC are involved. That means AP is cutting BC into two equal half. That is bisector. Perpendicular means this is equal to 90 degree. Either this side or this side. Both should be 90. So for that what we will do? We know already BP is equal to CP. Right? And just now we proved BDP. BDP is equal to CDP. So we can also say, children, in here BPA and APB and APC are also equal because we proved here, see, ABP and ACP are equal. If you take all these triangles, any one, you can see that APB and APC are equal. So angle APB is equal to angle APC. You can take this. From where you will get? You can get from here. See here. APB. Here you already proved, no, in the second point that this is equal to this. So if you see the pattern, APB is equal to APC. So you can go and write that APB is equal to APC. So APB is equal to APC, yes. But this is a line and this is a ray standing on it. So what do they form? They form linear pair. So you can say angle APB plus angle APC is equal to 180. And they both are equal also. So if this is x, this is also x. So instead of this I can write x plus x equal to 2x. So x is equal to 90. Now what is x 90, children? X is APB or APC. Therefore, angle APB equals to 90. So now you have proved that this is 90 degree. And here you already proved BP is equal to CP. So from these both things you can say AP is perpendicular bisector of BC. Thank you.